Good afternoon, everybody. Welcome to our webinar today. My name is Jeff Perkins. I am the CMO of QASymphony, and today's webinar is entitled Risk Mitigation Using Exploratory and Technical Testing, featuring Alan Richardson. We want to welcome you to this webinar, and we'll get it started. A few tips before we start on how to view this webinar to get the best experience possible. The audio for the webinar is delivered through your computer, so you have to make sure that you are either using a set of headphones or your speakers are turned up. If the audio quality is choppy, it could be related to your internet connection. So we recommend that you either hardwire in via internet or get closer to your wireless router, and that could improve the quality. You are able to customize your webinar viewing experience. You can increase or decrease the size of the widgets that you see on your screen. If you want, you can make that presentation bigger. You could also zoom in and out using the browser to increase the size of the presentation. And if you have any questions during this webinar, you'll see a Q&A widget there. So just place your questions in the widget, and we will get to as many as we can at the end of the webinar. A few housekeeping items. We are recording this webinar, so after it concludes, the on-demand version will be available. You will get an email with the link to the on-demand version. We also put the slides up on our SlideShare page, so check QASymphony's SlideShare page if you want to get a specific version of the slides. We are going to be live tweeting during this event, so if you use social media and you're on Twitter, please participate in the discussion using the hashtag #RiskTesting. So you could ask questions there, or just have a general conversation with your peers. Again, use that Q&A widget, and at the very end of the webinar, please stick around. You will have a short survey that you'll be asked to take. That'll help us gauge the success of this webinar and get ideas for our future webinars. So if you could take that, we would greatly appreciate it. This webinar today is brought to you by QASymphony. For those of you who are not familiar, we are a company that makes agile testing software. We have software that integrates with the most popular ALMs like Jira, Rally, and version 1. And our software is built around helping agile teams accelerate the speed of testing while at the same time maintaining quality. So if you want to learn more, take a free trial, please visit QASymphony.com. If you like this webinar, on QASymphony.com you will find other webinars, you'll find ebooks, blogs, so I encourage you, if you like the content here, to check out our resources page on our website. It has a lot of other great content there that we think you'll get a lot of value from. And now on to the main event. We're very lucky today to have Alan Richardson with us. Alan has worked in software development for over 20 years as a programmer, tester, test manager. As an independent test consultant today, he helps organizations improve their agility, technical skills, and testing processes. Alan wrote the book Dear Evil Tester, Java for Testers, and Selenium Simplified. He also created online training courses on technical web testing, Java, and Selenium WebDriver. Alan blogs at eviltester.com, seleniumsimplified.com, and javafortesters.com. You can find information on his consultancy, training, and conference talks at compendiumdev.co.uk, and follow him on Twitter at eviltester. So with that, Alan, I'll hand it over to you.
Excellent. Well, thank you very much. And the good thing about an introduction is I don't have to do that for myself. So welcome to the show. Right now, everyone is already familiar with risk, I assume. So what I'm going to try and do in this webinar is give you a slightly different view of risk and treat it as a belief model. And also what we're going to do is we often say things like risk underpins testing. So what I really want to do is use it to massively underpin testing. So everything in this webinar is going to be underpinned or derived from risk. The processes we talk about are going to be derived from risk. The reason for doing technical testing. The way that we approach testing. Everything we're going to use and underpin and derive from risk. Because if we do that, we can actually use those risks to justify what we do and why we do it. So, I have a fairly common sense view of risk, and I'm sure everyone else does. Risk is essentially something that might go wrong. right? The things that might go wrong, we tend to talk about as opportunities. Very often when we talk about risk, we talk in terms of probabilities or the impact. But again, those are beliefs. We believe there's a certain likelihood of something happening, or we believe that an impact is going to happen in a certain way. Very often people get hung up on that, and we'll discuss that later. So when I was preparing for this webinar, there were risks associated with it. Right? I was ill last week. I've got a cough now. You might hear it in my voice now. What if I still have that? The broadband connection might break. My phone might work, might not work. We might have a power cut. We had a power cut this morning. We might have a power cut today, even as we go through. Some of this we are going to try and mitigate. But essentially, a risk process involves us identifying all the risk, scaring ourselves silly by thinking about what might go wrong, then figuring out, are we going to mitigate that risk? Are we going to do something, take some action? Are we going to detect it, again, do something, take some action? Or are we just going to accept it and live with it? So with the webinar, I identified a whole bunch of things. You saw them on the slide. I scared myself silly. I did a lot of preparation. I tried to sleep a lot. And there's a whole bunch of things that I did. Some risks I accept. Right? This is a webinar. You might get bored. You might drop out. Some of them I'm slightly mitigating by adding some pictures later on. I could have attempted to detect some of the risks. Right? I could have another computer watching the webinar. But then every process we add into the process we do adds additional risk. If I try and detect whether we're going to drop the webinar, that might impact my internet connection with the megabits per second and impact the webinar that we're doing. So, like beliefs, we build on top of each other. Like risks, there are risks associated with the mitigation we do or the detection we do. Everything has risk associated with it. Because risk is everywhere. It's pervasive. Everything we do, we should pretty much try and fear everything. If you want a simple risk identification process, it's fear everything. If you're looking at your org chart and you don't fear that something's going wrong with someone in there, you haven't identified enough risk. If you've got a system model and you don't fear that something's going to go wrong with part of that system, you haven't identified enough risks with it. Now, that's not the most sophisticated view of risk, but it's an easy one to get our head around. So here's an example from my website. I have a contact form on every page on my website. And I regularly receive emails like this, spam emails that are using my contact form. Now, there's a risk associated with this, or at least one risk. There's a risk that I get so much spam email coming through that my inbox gets flooded and I don't get anything else done. All I do is process that. So having identified the risk, I could mitigate it. Right? I could add a captcha on the form. That would mitigate that risk. However, it has the knock-on effect that no one might contact me because I'm putting barriers in place. Every process we put in place to mitigate a risk has knock-on effects. We need to keep thinking through the processes and the risk chain as we go through. But we should also bear in mind that with every risk comes an opportunity. We often hear that problems are just opportunities we haven't taken advantage of. Risks are opportunities. That contact form sends me spam email. There are systems out there that will monitor websites and see if they're still up and running. I do not need to invest in one of those. Every couple of hours I get a spam email telling me that my website is working, and not just that, but my contact form is working. Someone else has spent time and money automating my website to give me this website uptime checker. So I don't need to do anything. That's an opportunity for me. Every risk is an opportunity for us in testing, either to detect it, to go deeper into our process, to improve our process. And we need to start thinking about it in that way and use it as something that massively drives and underpins what we do. Now, there are general risks that are created outside the context or system or environment that we're working in. General risks that we typically find in testing are this thing might not work, like just a functional risk. And a common risk is there's a risk that this change we're making might have a knock-on effect in the system, a risk of regression or a risk of change. Now, we have in testing something called regression testing, which is a process that people put in place. And I think most people think that that process is mitigating the regression risk, and that they've created that regression testing process to mitigate the regression risk. Unfortunately, they're wrong, right? Testing doesn't really mitigate the risk. The act of testing doesn't really mitigate the risk. If we were serious about mitigating the regression risk, we would analyze the change we're making, analyze the knock-on effect that it has in the system, try and isolate it, try and manage that change so that it doesn't cause a knock-on effect, try and do things in a quality assurance process to make sure that we do it right. Problem is, we believe that risk underpins testing, but we don't do enough carrying that forward to make risk actually underpin our process. So regression testing, whilst we do it, is really just an out-of-context process that we've stuck in place to make us feel comfortable, but it may not actually even mitigate that risk because it may not be targeted in the right places. So we need to do better than this. We need to do better than just having general risks. We need to get much more focused. Now, I assume that people, because risk is common sense, everyone uses it, that you're already using risk. And you're probably using things like business risk or project risk or functional risk, possibly even regression risk. Business risks tend to be things that are associated with the business. So we might run out of funding, there might be regulatory requirements, our building might fall down, right? Things that are less likely to get used for testing. What is much more likely to get used for testing are project risk and functional risk. Now, project risk are the kind of risks that you find when you're brought into a risk management meeting and you sit around for a couple of hours just coming up with risks. And it tends to be, we might not have enough staff, the users don't know what they're doing, the user's going to change their mind, everyone's going to have a holiday, the environments might not work. General stuff, right, that might impact the project, that if you're in there as a practitioner, you're probably not going to use for your testing. It's the kind of thing that the managers will worry about. What we're much more interested in as practitioners are the functional risks. So very often we talk about those at a very high level. So we'll talk about a user can't register on the site, or high level the payments might not work, or the reporting might not work. That's really too high for us to really drive into and deal with, which is why we're going to talk later on about doing this a little bit better. So one of the things you notice about risk, and when you start doing risk research on the internet, you'll see that people get hung up on the probability part and the impact part, particularly if it's in a risk management meeting. So what you'll see are formulas like this. Hugely complicated formulas where we have to guesstimate some probability and guesstimate some impact and stick it in a spreadsheet. And all of this is, and you can read this here, priority and probability procrastination for project head person protection. Ultimately, this is risk mitigation so that managers don't get blamed if they focus on the wrong risk. We need to do better than that, right? We don't want to just put things in a spreadsheet and have the spreadsheet tell us what risks to focus on because we're scared we're going to pick the right ones. We need to identify real risks that are very focused for the environment that we work in. So I did some other research for this webinar to look at how people who define things define risk and risk-based testing. So I went on the ISTQB stuff, and they have a lot of definitions related to risk. They have an online glossary website. Since it's a website, there's risk that it might go wrong. There's a risk that I do a search and I get back completely irrelevant definitions. There's a risk that this site may have been vulnerable to SQL injection and someone has put in really bad definitions for us to look at. Now, when this site was released, it was vulnerable to SQL injection, but I raised that with them and they fixed it. So hopefully, all these definitions are good ones now. So here is the ISTQB risk-based testing definition. And it says, an approach to testing to reduce the level of product risks and blah-de-blah-de-blah-de-blah-de-blah. Right now, when I'm faced with text like that, I mean, I can't read it. I can't read it straight off. There's a risk that I'll fall asleep, hit my head on the desk and die or go insane or whatever else. So what I have to do is decompose it. I have to do some analysis on this text. So pulling apart this definition, what I think they're saying is, we approach the testing to reduce the level of product risks. There's some sort of mitigation action. Now, I don't know if this means reduce the number of product risks or reduce the severity of the product risks, but I think they're talking about mitigation, which is slightly different than the way that I talk about risk. I can see also that they're talking about informing stakeholders of the risk status, which is good. In order to do that, you have to detect the risk and then tell people, we found it all the time, we couldn't find it. There's also the analysis to identify the risks that we're going to look for in the first place. Prioritization of the risk using some sort of risk leveling, possibly asking someone, is this important, should we look at this? And using the risk to guide the test process, so some form of derivation. So that's good. I understand their definition now. I can see that in my world, their definition overlaps what I think of as risk management and what I think of as testing. So the mitigation part, I think, falls into risk management. Mitigation, detection, analysis, prioritization, that's a normal risk process. What I think testing adds is the notion of using it to derive coverage so that we target the risk and see if we can make it manifest. But I don't think the act of testing mitigates. I think process can mitigate process risk, and we'll cover that later on. So I classified the risk into functional risk, we've discussed system risks related to how things are put together, technical risk as in terms of product, these are all kind of product risks. Then we've got non-system, non-product related risks like the process, the business and the project. Now the process risk is based on the system of development, the way we develop stuff. Now, what we're going to focus on in this webinar is the technical risk and the process risk, because I don't think they are as well covered in the literature. I've got some references at the end of the presentation, so you can look through those later on at your leisure. But what we're going to look at is process risk and technical risk, because if we focus on those, we can actually use process risk to derive our process, and we can use technical risk to improve our skills and go much more deeper into the functional testing that we carry out on an application. So, I mean, I talk a lot about models and I talk a lot about systems. So we know that we've got the system under test, the thing that we are testing. I also think we've got a system of development, the way that we develop software, how we do it, what processes we use, what tools we use, what skills we've got. All of this, when we model it, becomes a system of development. And the way that we develop the software opens us up to different types of risk, and that is why we adopt different approaches in how we test. We use the risks inherent in our process to adapt or define our test process. So before we move forward, we're going to have a quick survey. Do you currently take an exploratory approach to your testing? If you take 10 seconds to answer this, we'll see how we get on. This is a new thing for me, asking surveys in a webinar, so I'll be interested in seeing how this works. I'm going to give you 2 seconds. 1 second. Let's see how we did. Oh, so a lot of you do use an exploratory testing approach. Some of you are working on it, so that's good. This will help you. Some of you are not. Hopefully we will cause you enough fear that you will want to after this. So those of you that do, you can see whether your exploratory testing approach is built on a risk-based premise as we go through. The reason I like to model this in terms of risk is that the same skills that we have for working with the system under test, we can apply to a system of development, because essentially testing skills apply to systems and apply to models. And if we model everything as systems, we can use the same skills. If you model people as systems, you can use your testing skills on people, which may or may not be a good thing to do. So essentially with process risk, we have to analyze the process, see if there's any risks that we can find. And the easiest way of identifying risks in a process is seeing what issues they have. Because if something sometimes goes wrong and sometimes doesn't, it's probably because there's a risk that hasn't been addressed. Then we can change our process to mitigate that risk or detect it so we can report on it, or just accept it. And if we accept risk, it's important to tell people that we have accepted the risk so that they understand what problems are likely to occur. Now, every process has risk in it. If you're using a waterfall development approach, you're very likely to have a structured and traditional approach to testing. You're very likely to be writing test cases and test scripts and plans and strategies and whatever else. Now, that structured approach fits into a waterfall development, but still has risk in there. You can't accurately estimate, although you're expected to. Development that might overrun, your testing is going to overrun, but it's going to get squashed. You've created so much stuff, there's a high risk of waste. You can't change things fast enough because the requirements are going to change, and you've got so much stuff written that is cross-referenced back to anything else. Even though the processes fit together well, there's still risk. But it becomes worse if we use processes that don't even fit together well. If we're using an agile approach to development and we still try and use a structured or traditional approach to testing and write cases and scripts and plans, testing is guaranteed to be too slow. It's not going to fit into the sprints. It's not going to add any value because you're not going to test until the end. People are essentially going to say we don't need testing because you're not essentially doing any testing. So we have to view systems as a process. So here is a model of a modern development approach where we've got stories, we have conversations about them, we write code, we try and automate at the same time, we do some exploration on it to see whether it's working or whether it's problems, and then we just magically say it's done because we all agree and everyone's happy. Now there are risks with this process, as with any process. Right, there's a risk of miscommunication because we're having conversations, which leads to misunderstandings, so we code the wrong things. So we have errors of omission because we forget things because we didn't write them down. There's bugs because we're human and we make mistakes when we code. We try and use the wrong tools. We try and automate too much. We write the stories too early, and therefore we have a lot of waste, etc., etc. There's risks with everything. One thing we might do, and you often see this on Agile projects, is we've got a tech debt mitigation. We have a big pile of stuff we didn't quite finish. That itself adds a massive amount of risk in our process. It's not really a mitigation, it's much more of an acceptance that we're doing things wrong, but we haven't fixed them. So for testing, if we are identifying these risks, we can change our process to mitigate the process risks. If there's a risk of misunderstanding, we can have a process where we discuss the test ideas and possibly write the test ideas down so that people know what we're going to test, which might help with omissions, so that people know what they're going to test, so they'll code for it. If we're doing exploration and people find it hard to know what we've done, it's a risk that they don't understand what we've done, then we can log the testing that we're doing. We can do it in small chunks. We can debrief so that people understand what we've done. That might cause them to realize that there's something else wrong somewhere else. Everything's time boxed, so we might overcommit or there might be emergencies. There's risks in every process. So what we have to do is analyze this and figure out what we're going to do. Because process risks are a result of the system of development. The system is built of interconnected teams, individuals, the relationships between them, the communication that they have, the artifacts that are built or not built, the timings between when processes start, what's running parallel, what depends on something else, what the expectations are, etc., etc. Right? We need to get in the habit of modeling the systems that we use for development in the same way that we model systems under development. And then we can test effectively. Now, one of the reasons that I talk about risks in terms of beliefs is that it's an easy way of understanding why, when a process doesn't work, and we know it doesn't work, why we don't change it. The reason is because we're dealing with beliefs, right? We need to start thinking, what do I believe might go wrong? The likelihood, the impact. What is likely to happen if I go into battle on a lobster or a tortoise? Do I believe this is actually going to make things better? Do I believe there are any risks with this? Does this seem like a good plan to me? We're thinking this through in terms of beliefs and our models of the world. And when we do that, we have to start talking about secondary gain. Secondary gain is the unrecognized benefits that are in there. You find this a lot in psychotherapy. People target secondary gain. If I'm a smoker and I know there's a big risk that I might die, which is quite an important thing, there's secondary gain involved in the act of smoking. Right? If I'm smoking, I get to take breaks outside, presumably in my pajamas carrying a stick. I get to chat with other smokers and socialize, and this is stress relief, and I get lots of breaks. If I attempt to give up smoking, my secondary gain goes away. I don't get to go breaks. I don't get to go outside. I don't get fresh air where I'm smelling cigarette smoke. I don't get to chat and socialize, and I get tense, and then I drink more coffee, and then I get tenser. And there's no secondary gain. And what we have to start doing is identify that secondary gain and target it, because that's what keeps us going. We know that risk keeps testing in business. That's why we test. If we remove all the risk, we might not need testing. So let's not target the risk properly. Let's not mitigate. Let's just put in process that seems to mitigate it but not do it. If we come up with standards, process risk justifies our standards. If we remove the process risk, then we have to amend our standard, and then we have to do things differently and then take responsibility, and etc., etc. Right? In every process, you'll find secondary gain. Some developers like Agile because they don't have to write anything down and they can just code. Secondary gain, they don't have to write anything down, so they don't write anything down, so we have miscommunication. If these are risks and there's secondary gain associated with it, if we identify it and change our attitude to it, we can target it. Because fundamentally, we do not want our testing to be limited by our beliefs. Right? Because there's only so many things that we believe are going to go wrong with our model of the world. It's why when we have risk meetings, we have lots of people in the room so that we get lots of different opinions of what might or might not go wrong. We have to learn as testers when we're working on our own to go further than that, faster than that, and better than that. Now, I don't normally like promoting the 5 whys questioning approach. It's where people use 5 whys to do a root cause analysis. So they'll say something's gone wrong, why did it happen, then why did that happen, then why did next? And they believe that they're following through a root cause analysis. What they're actually doing is investigating a belief chain. Right? Why do I believe this happened? Why do I believe that happened? Which is great for us in terms of risk, because risks are beliefs. So we can follow that. We can ask questions like, well, what else might go wrong? Use our imagination, because there's an endless amount of things that could go wrong. We can also do systems analysis, as we've seen. We can build models, we can break them apart, we can look at the communication links, we can treat the inputs and outputs. We can do a whole bunch of ways of modeling it to overcome our simple view, which is what do I initially believe is going to go wrong. So I have some fundamental beliefs about process. I believe the more complicated a system is, the more risk that can go wrong with it, so I want to simplify my processes as much as possible. I don't want complicated processes that can go wrong. I don't necessarily want to build processes built on what someone says they need. I want to build processes based on risk, because then I know it's a problem that we're tackling. And I find that when I do this, it leads me to build an exploratory test approach rather than a document-heavy, structured approach. So one of the questions is, before we get to the technical part, is do you use, or do you believe that you use technical knowledge and technical risk analysis to prioritize and derive your test scope? We're going to cover technical risk later on, so you've got 10 seconds counting down to see whether you use technical knowledge and risk analysis. 2 seconds. And we're done. I'm going to advance us. Let's go. Ooh. So some of you believe you're using technical knowledge. Some of you don't. I don't know if you're proud of that or not, but let's see as we get through. Because what we're going to do is we're going to explain why you would want to do this and how to do this. And it's good that some of you are working on that, so hopefully this will help you. So, risk and exploratory testing. when I build, say I come into an organization, there's a lot of people talk about context-driven testing, which essentially means taking your context into account to build your process. So you don't just come in with a process, you use your environment, your system of development, your context to work out what to do. So say you've built a thing, there's this metal thing and we've built it, but we don't know how to test it. So we don't have a test process. So we're going to try and build one. Now the easiest way to do this is to just ask questions. Well, who's going to use it? What's it supposed to do? What data does this process? And then we'll try and figure this out. But fundamentally, these questions are related to risk. We don't know if it works. There's a risk there. There's a risk that it might not meet the user need. Therefore, what we'll do is figure out, well, who's going to use it? How are they going to use it? What are they going to use it to do? We build processes, mitigation processes, like sausages, that will target these risks. Now what's interesting is these risks that we've identified here, it might not meet the user need, it might not function, it might not handle input. If you look in the exploratory testing literature or the context-driven literature, you'll see a whole bunch of mnemonics and heuristics out there. And what we've built here is actually a process that looks remarkably like one of James Bach's mnemonics, San Francisco Depot, where we're looking at the function of it, the operation of it, the process, what input does this thing have to process. But we've built this from first principles by looking at risk. And that is what I would like to see more people do. Once we built a basic process around what are we most concerned with, we can then start refining our process in terms of looking at other risks that manifest or that we identify. There's a risk when just because we're looking at functions that we might not have tested enough. Therefore, what we'll do is we'll agree high-level conditions in advance, we'll review them, make sure they're important, and we'll do work and then we'll review what we've done and make sure we do that iteratively. If we can't tell people what we're doing, we'll learn to make notes. If we can't plan, then we'll agree some time constraints, we'll do something, we'll report back on it. And this is very like the exploratory test management processes that you see documented, because they're targeting risk. They're not targeting need. We haven't put anything in here where management has said, we need a giant report that tells us what you're doing, because we're targeting the risk that people don't know what we're doing, rather than their need or perceived need for reporting. And the more that we can target risk rather than need, the more we're going to build processes that actually target what's going on. Now I have no idea what's just happened to this slide because I'm faced with a blank slide here. There we go. So I'm going to move on to technical risk now. So as I go through these slides, as an exercise to the reader or the viewer to make sure you're still awake, what I would like you to do is think, for the models that are on the screen here, what technical knowledge do you have that applies to what's going on here? What technical risks do you see? What gaps do you spot in the information that I'm putting on screen, which is derived from your understanding of the risks that are present in the model that's currently being presented? What tools would you use to help you with this, and what risks do those tools target? Right? Because we introduce tools to target specific risks in our process. So here's the basic system. We have a login form which communicates, it's a web page, so it communicates with a server, and the details are in a database. That's pretty simple, we've all seen that. So we ask someone what the requirements are, and they tell us, well, you have to type in the username and password correctly, and you're logged in, and if you get them wrong, you get an error message. If that was all we used for our testing, we would have a problem. So if there's a risk, the acceptance criteria is not good enough, so we have to mitigate that risk by asking a lot of questions. Now at this point, we can't ask questions based purely on the acceptance criteria because they're fairly small. What we're doing is we're using a general understanding we have about login processes, the login domain, and that's where we're drawing these questions from. How often can a user try to log in? What if you're already logged in? What happens? What error message is displayed? What happens if your username's blank, your password blank, whatever? We're using the login domain process to ask more questions, and we'll get nuances back in the answers, so we'll start to learn that the user can log in 10 times and that is tracked by a cookie. JavaScript is used for validating the username and password and whatever else. But that login business domain type only goes so far, because essentially we're working with websites, which is in a browser. And when we're dealing with a browser, we don't have the concept of username and password, we have the concept of text input fields. And text input fields we can put URLs in there, we can put Unicode characters, and we can control the length of the number of characters put in there through JavaScript or using the HTML attribute max length. And that's what we're doing here. To maximize the number of characters you can put in the username, we'll set the max length to 20, so the username can only be 20 characters. Because it's a browser, we might realize, wait a minute, there's more than one browser. So we have to test for browser compatibility. Now, hopefully, we understand why we might want to do that. So we don't just test this website on every single browser going. We understand that there might be a technical risk because of some of the CSS we're using, or some of the HTML we're using, or the JavaScript might not be compatible. And we're not just doing it as a blanket, it works in a browser, therefore we test in every browser. Hopefully we say, because we know the implementation has this specific technical implementation, there might be a risk on this particular version. And then we use that technical understanding to guide what we're going to do. And what you'll see is we've got a little bit more technical with each stage we went through, and we got more technical information back. So for me, technical testing is simply testing that's informed by a technical understanding of the system. Right? I'm not talking about programming, I'm not talking about automating, I'm talking about technical knowledge applied to the act of testing so that we identify more risk, so that we go deeper into the system, so that we take our requirements and we push them further and further into different domains and different dimensions of this system model that we're working with. So let's build a technical model from the information we've got. Right, when we were discussing the high-level requirements, we came up with a few technical pieces of information. We learned that there's a failed login cookie. We learned that JavaScript's being used for validation and to disable forms and whatever else. Technical knowledge means that we can identify risks with that. Now, hopefully you've already identified some in your head, and you'd be able to use those for testing. Essentially, and here's a few, there's way more than this, but I've come up with a couple here. There's a risk that a user disables cookies. There's a risk that the user amends the cookie in the browser. Now you can see that what I'm doing here is I've just come up with, well, what if questions, but those are risks, right? There's a risk that if this happens, we may not have covered it because it wasn't covered by the requirements. Now, in order to come up with this, we have to have some technical information. Right? We have to have technical knowledge. We have to have knowledge so that we can spot risks in the requirements, to identify the what-if questions. I mean, we will only know that there's a risk with max length if we understand HTML and know what that field does. And if we know that you can edit HTML in situ in your browser, the user can take your page and edit it in the browser using the dev tools. They could change that. They could delete that attribute. If that's the only control that you have on the length of the field, it's not good enough because the user can delete that in the browser and send through whatever length of field they want. And there's a whole bunch of risks in here, or a whole bunch of extensions for our technical knowledge that will lead us to different risks and different testing. But we only covered there the browser. Now, if we only have technical knowledge that extends to the HTML in the browser, there's a whole bunch of testing we're not going to do. We're not going to target the server. There's a risk that the validation we do in the front end doesn't match the validation at the back end. That might cause us a problem. We might test for that by looking at boundaries, and we might be lucky and might catch that the front end lets us do 20, but the back end is limited to 19. We might catch that with some very simple boundary, but much more likely the validation rules are completely different, and it's hard to test for that if we do all our testing through the browser, because we have to figure out how to bypass it. So we have to learn how to interact with our system at the different levels that our technical model exposes. So we have to learn how to interact with the system from a browser, learn how to interact with the system at the HTTP server. And when we're doing that, we have to learn what an HTTP message looks like and understand that there's headers and what happens if we, because we're dealing with login, the basic auth header might be important. That might give us a risk. We can model a whole bunch of different things from our technical knowledge. Now the hard part is knowing exactly which ones to target, but that's why we discuss this and phrase this in terms of risk, and people can prioritize for us. But in order to do this, we would need to know about HTTP. We would need to know how to observe HTTP traffic, how to manipulate that traffic to actually test under the browser, test directly into the HTTP server. We might want to access the server logs so we can see if the application is throwing exceptions that are not reported to the GUI or through the HTTP messages. The more that we understand how the system works, the more we can figure out, how do I observe this in action? How do I interrogate this in detail? So what we've essentially done is we've gone from a very simple acceptance criteria. We've applied a kind of business or logical domain on top, and we've just kept adding more dimensions or more models and expanding them in more depth. And your testing is limited to the extent that you build and expand these models. The more technical information you have, the more you're going to build a broader technical model around the system that you can target and use for risk analysis. Now, clearly, with every process, there are risks, right? There's a risk we don't have the skills to do this. There's a risk that people don't want to do this. Our staff don't have time to learn. They don't want to learn. There's a risk we're not allowed to use any tools in our environment. We can't, these are all risks, and we have to decide if these risks are important enough to mitigate or whether we acknowledge them. We just accept these risks. But the whole point of doing these kind of webinars and these kind of talks is so that you're aware of these possibilities, that your beliefs around what you could do expand. Now, the risks of not doing this, to me, are more important than the risks associated with trying to do it. Because you've seen that the system models expanded the coverage of our testing, so there's a risk that if we don't do this, that we miss entire areas where errors could exist in our system. We miss entire areas that no one else ever looks at. And the errors that slip through from these type of places can be massively system threatening. And the easiest way of doing this type of testing, of targeting this type of risk, is through exploratory testing, because it's an ongoing learning and exploratory process where we agree in advance whether it's important enough and we go and investigate it for a short time-boxed period of time. Not something that we script in advance, it's something that we trigger through risk. So I think you can approach this in two different ways. Right, there are a whole bunch of mnemonics and heuristics out there. You can use those as guides. I've got a link to a whole list of them here. There's a whole bunch of resources listed too in the slides when they get released. They're a good stepping stone for going forward. You saw that earlier on when we were building an exploratory risk model that James's San Francisco Depot heuristic mapped onto that, or his mnemonic mapped onto that. You can also work from first principles, which is what I tend to do, where you build a system and technical model. You look for gaps in your model, you look for what you understand and what you don't, you look for the communication links, and you just do systems analysis on that and try and break that apart. However, both of these approaches, in order to maximize the benefit, require you to have technical knowledge. If you don't have the technical knowledge to identify the risks, if you don't have the technical knowledge to know that when someone says structure to you, that you have to look at the structure of the system and its interconnecting parts, and because it's using Jetty as opposed to Apache, there's a different set of risks. If you don't know that, you're not going to do the testing even if you're working from mnemonics or the system. But both of those are valid ways of going through. Now, I think the decisions you have to make are fairly simple. We have to ask ourselves if we're prepared to increase our technical knowledge and if we're prepared to put the time and effort in to learn more. Whether you do it individually, whether your company gives you the time or your manager gives you the time or you make time on your project, we spend a lot of time learning how to test. Are we prepared to spend enough time to expand our technical knowledge as well? Now, I know there's a massive amount of information to learn when we start approaching the technical aspects of what we do. I mean, this is what's great. I love this because there's so much more to learn. Every project I go on uses slightly different technology, which means there's more things to learn, and there's more people to learn from, and I work with the developers to learn about this new technology they're using, and do risk analysis to figure out what might go wrong, look at other places. And so the way that we target this is by looking at the projects that we're working with, learn the technology that we're actually working with, learn about it in small chunks, and drill down a little bit further. When you discover something that you don't understand, that's the next thing that you have to put in your model and research and keep going. And the point here is, if we keep doing this through our project and keep applying what we learn, we're constantly going forward and keeping up to date. If we go away and read a book for a month and then come back and try and apply that knowledge, that's not going to work. What we have to do is read a page and try and apply that page immediately. Look at the technology, go away and jump into the middle of a book and read that to learn about the technology we're using. We have to target it based on the risk that I have a gap, I've identified a technology and I don't know how to do this. So here is my high-level underpinning guide for what I do. I said I model things, I model things. Everything becomes a model and I look at that for gaps. I look at the HTTP traffic, do I know that? I start looking at I start observing things, so I start observing the HTTP traffic. I see things I don't understand. I don't understand these HTTP headers. That's a new thing in my model. I have to go and research. I have to go and reflect on this to work out what the gaps in my model are, how I'm going to expand this, how I'm going to use this in my testing. I need the ability when I test to interrogate the system. So observing is looking at things and passing. Interrogating is driving in deep into the system when I need it to look at it in detail. And manipulation is how I interact with the system. If I only know how to manipulate the system on the GUI, then my testing is only go so far. If I know how to then push it to manipulate the HTTP traffic, I can extend my testing and do more things. So this is my high-level guide, and that's how I pick tools. How can I observe the HTTP traffic? How can I observe the server logs? How can I interrogate the database? How can I manipulate the HTTP traffic? How can I manipulate the database directly? And again, there are risks with this. There are always risks. There's risks when we're learning that we go a lot slower. There's risks that we raise we point things out that aren't errors, but we think they are because we don't understand them. There's a risk when we do this that we go down rat holes that lead nowhere. So we change our process to mitigate them. We do them in small chunks. We time box our investigations. We agree in advance we're going to have a look at it to see if it will help. We agree the time we're going to spend on it. We don't go away and evaluate tools in isolation. We use them on the project and see if they work. We try and address these risks through changing our process so that we can mitigate them. Now, I understand practitioners are going, okay, I'll try this if my manager gives me time, and the manager might be thinking, well, I don't understand what the system's doing. I don't really understand what the guys are doing because they deal with the process and project risks. Now, that's okay because the technical staff are going to understand this and they're going to look into it. And fundamentally, it's every individual person's choice whether they improve their technical skills or not. It's the manager's job to assess whether this is a risk, whether we are not testing technically enough or not, and whether we should do something about this, whether we should mitigate this risk or do we accept it. Do we then start having team meetings where we share our models of the system, share our technical understanding of the system, and see where the testing can fit. Share the tools we use, share why we use those tools, what risk do the tools mitigate, are we observing, are we interrogating, how can we manipulate the system at lower level. Building a process around that will help the team become more technical. People might not want to do that, but it's the manager's job to try and build a culture that mitigates the risks in the system of development. So I'm almost at the end now, which I think is good for time. So we test systems to the level that we understand them enough to observe their behavior and compare it to our model of how we think it should behave. Essentially, my testing means I have a model of the system. I do things to the real system and I observe that system in action. I compare the observations back to my model. If the observation confirms my model, I probably haven't learned very much. If the observation makes my model seem invalid or exposes gaps, then I may have found something I need to go and research, or I may have found a bug. We test systems at the places where we can manipulate them. Right? If we only can manipulate at the GUI, we're only going to test at the GUI. If we can manipulate at different parts in the technology stack, our testing can be done differently. It will find different errors as a result. And we test systems to the level that we can interrogate them and understand the data that they process and produce. If I can't see the data that's going on, I have to trust what the GUI is telling me, that the GUI might be lying. There might be an entire set of exceptions thrown in the server logs that I can't see because I can't interrogate that. So expanding our technical knowledge expands our models, our capabilities, our ability to observe, to reflect, to interrogate the system, manipulate the system. And fundamentally, expanding our technical knowledge expands our ability to test. And the risk of not doing that is not one that I am prepared to take, but fundamentally it's an individual choice for you. So thank you very much. I think I'm going to hand over to Jeff to see what's going on.
Great. Thank you, Alan. Great. That's great content. So we got a couple questions in from the audience. So if you could, if everyone wants to stick around for a little bit, we'll answer your questions. You can ask them in the Q&A widget. And just a reminder, we have a survey that will pop up at the end of the webinar, so please stick around to the end so you can take that survey for us. But the first question is, how do you deal with situations where your own appetite for risk appears to differ from those of your employer? What would you say people should do in that case?
That is a good question. How does my appetite for risk or anyone's appetite for risk differ from our employer or our stakeholders? And that will happen a lot. And part of the reason that will happen is because we have different models of the world, right? So they're very often looking at it from a very high level. You're looking at it at a low level, so you see different risks, different models. So I approach this in a couple of different ways. Sometimes I will try and convince them. Sometimes I will try and make them scared because I'm talking about fear, I'm talking about beliefs, I'm talking about risks, I'm talking about what might go wrong. Sometimes, because I'm taking an exploratory process and I can work in very small time boxes, I might go away and investigate that risk partially to convince myself that the likelihood of it happening is very likely, less likely, not likely, so that I know whether it's a battle I want to fight or not. So sometimes I'll go away and I'll look for more information before I actually tackle that. Sometimes I'll just go away and do it because it will be an interesting learning exercise for me. So I might do that over my lunch break or do that in my spare time to really investigate it, because then I'll learn more about the technology. So I approach that in different ways, and it's going to come down to your personal style and who the person is that you have the disagreement with.
Great. We have a couple questions around technical competency. One of them is there a basic list of the minimum technical proficiency a tester should have, and what would be on that list?
So someone may well have created that list. I haven't. I've got a small online course that deals with basic web testing and web technical skills. But if you're testing web, so I think what it comes down to is whatever technology you're testing, you need to start understanding it. And the basics is, have you even read a book on that technology? If you're testing websites, do you understand HTML? Do you understand the basic technologies? Do you understand HTTP? Have you ever built a website? Because then you will have some insight into the risks that are going on. If you're testing mobile, do you understand the platform? Have you ever built an Android app? Do you know how to run the emulators? I mean, it's hard to know what that list should be, but the basic approach is whatever technology you're working with, write down what you currently understand and figure out, do I really understand this, or do I just know the words? And if you just know the words, then you need to go and research it so that you start to understand it. Then underneath it, you will build a new set of words, and then you keep going.
Terrific, terrific. We had a couple questions come in around the balance between exploratory testing and automation. How would you advise people kind of to manage that balance between how much I automate versus how much is exploratory?
So the interesting thing is, I tend to, because I'm modeling this as the system of development, for me it's the notion that on our project we are going to automate some things, we are going to explore some things, we are going to code some things. The question kind of suggests that it's being looked at from a tester perspective, where they have to split their time across automating things or exploring things. Very often, so if I'm doing that, if I'm in the position where I'm the tester and I have to split my time between automating things and exploring things, I make sure that the automated work I do augments my exploratory work. So I write code that I can use to explore. I'll write high-level abstractions in the automation that I can use to build exploratory code with. So I will build a whole set of data, feed it through a small script that is using high-level abstractions to help me explore, to augment what I'm doing. So I try and kind of munge the two together. And I'll use a lot of tools to help me observe what's going on, interrogate and manipulate the system. But it's hard to come up with any general rule, but I try and make the two fit together.
Great, great. Now, we had a couple questions come in around ERP systems and systems that are highly complex, and you know, when you are releasing new features, it's virtually impossible to test everything. And the question is, how to identify areas that can go wrong in a very complex system that is continuously changing? How do you mitigate risk in these large ERP systems?
Very often you mitigate risk in a large system by treating it as a collection of small systems and mitigate the risk lower down. And I think that essentially is what you have to, the risk is, if your only testing is from the outside in, and you've got this huge mess of interconnected things in the middle, it's going to be very hard to mitigate that risk. So you have to convince yourself that the stuff you're connecting together works fairly well, so that when you go to the next level out, what you're doing is you're not looking at the way that that thing functions, you're looking at the relationships it has with the other things on the outside. And hopefully you've mitigated some of those communication risks early. So it's about chunking it down into different ways to try and decomplexify what you're actually looking at.
Great. What are some good ways to keep stakeholders updated with testing coverage when testing focus changes as risk is being assessed?
So I guess that depends how close you're working with them, what type of project, what you're testing. And that becomes agreed with what they are concerned about. Because it's very easy to come up with an idea in isolation without consulting them. So if we were doing a lot of work and we had a system model, we could communicate all the testing we do in terms of coverage through that model and mark blobs on that model. We've covered this system in a lot of depth and not a lot in the other. But the person that you're talking to might not share that model of the system. Their model of the system might be based around requirements or high-level functions or high-level functional risk. So you have to communicate it in a term that they are going to understand. So again, it's hard to answer that other than when you're communicating anything to someone, you have to communicate in a form that will fit into their model of the world. And if you do it based on risk in terms of what risks are they concerned about, then you might be able to limit your communication to what fears and concerns they have.
Great. Well, Alan, I want to thank you for your time today. I want to thank our audience for joining us. As a reminder, we're going to have a quick survey pop up at the end of the webinar, and this webinar and the slides will be available on demand. It'll probably you'll get an email tomorrow with the link. So thank you again, everyone, and we hope you enjoyed this. And check back for our next webinar. Thank you.